Hello everyone, welcome. My name is Güray Baydur and I am from IBM Turkey Istanbul Developer Advocacy Team. And in this video, I'm going to introduce you a code pattern that uses IBM Cloud open source, IBM Cloud technologies, and we're going to develop an application that does data science and some AI technologies together. So in this GitHub page, you can also find it in the attachment. You can take a look at the code pattern with the necessary informations provided in the README file here down below. And you can also go through it. But in this video, I'm going to make you familiar with it. So let's start. So we're going to create an assistant that will estimate real estate prices. And what we do is we use the data set from Kaggle here, and it's a sample property information database, and that the dataset includes some features of a house, like the square footage of the house, the capacity, the rooms, and with these features provided, we're going to study the data. We're going to analyze the data, and we will make some predictions for the incoming, the new properties to be built, and we're going to guess their prices to gain insights from our data. So like this, we're going to, which technologies we're going to use? We're going to use AI, we're going to use microservices, we're going to use conversation, data science, machine learning, microservices, object storage to store our data, and Python. And also we're going to use some libraries like pandas, Apache Spark servers, and so on. So you can also find the descriptions that I said before, like the data set, like where we provided that data set, and also the insights of the data set, and also some details about the flow of the code pattern, and so on. And to introduce you the services here, you can, the user, this is the architecture diagram, first of all, and the user will go into the IBM Cloud and go to the Watson Studio, and they will create a workspace here, and they will first create a notebook and then download the dataset that we provided to the Watson Studio and study it, prepare it for modeling, and then we're going to, after data preparation sections, we're going to extract the dataset from Jupyter Notebook, and we're going to give it to the IBM Machine Learning Service, Model Builder Service, to choose the best modeling algorithm for our dataset. And then after we get the perfect dataset from perfect model algorithm from dataset from the IBM Machine Learning Service, we're going to go back to Watson Studio and calculate the accuracy, first we were going to implement the algorithm that IBM Machine Learning Server suggests us, and then we're going to calculate the accuracy to see if the machine learning service worked correctly, and also improve our data science knowledge. And afterwards, we're going to connect it to our assistant to to connect it to our Watson Assistant server, to chatbot, we're going to implement WebSocket communication protocol in IBM Watson Studio and also in Node-RED. Node-RED, we're going to use IBM Node-RED service to create the WebSocket server and also implement some functionality of that server, and also connect our Telegram bot, connect the Telegram to our chatbot, Watson Assistant service in the background. Therefore, and we're going to build the Node-RED service inside IBM Cloud Kubernetes service to demonstrate the application of microservices. So why don't we just go into the demo so that we can understand it much better. So the first part is, you can also find it in the guideline in the .readme file. First, as a user, we're going to sign up or log in if we have already an account to the Watson Studio, and we will create a Watson Studio project. So let's go into first and IBM Cloud, and if you sign up or log in, you're going to be forwarded this page. This is the IBM Cloud dashboard page. So you can find the resource summary from here, also some location statuses, some plant maintenance information, and so on. So you can follow up every need for your services from this dashboard page. Here you will, if we had created before some resources, some apps from IBM Cloud, we're going to find it from here. But since we didn't have any application or resource yet, we couldn't see here any resources. So let's go into creating Watson Studio for our data science analysis. So let's go to the catalog tab here. Just click it. So we are here. We are in the catalog page. So in the catalog page, we're going to study Watson Studio. So type in Watson Studio here so that it comes here. We'll click it, and this is the main page of every service in the IBM Cloud catalog page. So it will look, each service, they have their own specific configurations, but mostly it looks like the same. So we're going to give it a name, like for example in this particular case we're going to say like demo Watson Studio. So you can choose the region in which data center you're going to deploy the application. And so in this case, since it's closest to me, I'm going to use London. You can use wherever you want, like click on here and choosing other locations. But for now, we're just leaving it as London. So we're going down, and you need to choose free, as we don't need to pay for any services here. We can use it with light plan, which have some limited usage here. So that's it. We're going to click create, and we are going to be forwarded to IBM Watson Studio service. That will take just a few seconds. So here it's the main page of the service. We need to click get started to go into the IBM Watson Studio's main page. We clicked it. So verifications. And after that, we are logged in. Good, great. So this is the IBM Watson Studio's main page. It will greet us like this, and we can create a project by clicking here. That's what we do right now. We're going to click the create a project section, and then we're forwarded to this page, which will choose a project. You can have a look at here and choose whichever technology you want to use. But for example, you can have streams.flow for streaming data sets if you're going to analyze, or deep learning service, or data science service, or visual recognition service. In our case, we will use standard, which includes most of the data assets. So we're going to click the standard, and we will give a name for our project, demo application, demo project, I would say, demo project. So we can give a description here, but we're not restricted to that. So I will leave it as it is, and we can also restrict the collaborators from here. You can work collaboratively with your friends in IBM Watson Studio, which is a perfect feature. And also we need to give a storage service to our Watson Studio service. Watson Studio uses Cloud Object Storage, which is a good storage, since you can also give some images or audio files to it, and it will store it efficiently. So we will click, since we didn't have any sources before, we need to create a new storage service here. So we are going to click this, and we're going to choose a new. I mean, in my case, I created a new one, but I created because it's my other account. So I will wait you a real small time. Yes. Yeah. You will be seeing this page actually. So in the name, we are going to say demo. Yes. And then we're going to add a new Cloud Object Storage service. So click on add. Good. We are forwarded to IBM Cloud Object Storage Service main page. We can have a look at the information from here, but we will create, as before in the Watson Studio, we will create a free plan, light plan service, which is free with the limited usage that is provided here. So just go on and click create to create a new one. And it's the confirmation section. To make it clear, I will say demo, Cloud Object Storage demo, which may create a conflict here, because maybe if there's a Cloud Object Storage service with the same name, it will create crash. So why don't we give a unique name like demo code pattern, or just say CP, demo CP. That would be okay, I think. So we clicked on create to create our Cloud Object Storage service. So what is a nice feature of IBM's Watson Studio is that if we go in here and click refresh, we will see our service here. You don't need to choose from a list that's like I showed you before. If we click on refresh, you see that it is connected to our service. So we need to create it. Great. We created the project, so we can have multiple notebooks in this project, so multiple like analysis in our project to create our application. So let's take a few seconds. So there it is. This is the project main page of IBM Watson Studio. I'm going to I'm going to skip the tutorials. If you want to go into deep, you can watch the tutorial. You can go through the tutorial. So in this page, you will see like lots of tabs, lots of bars here, but we're mainly focused on assets and also settings, because we're going to create a notebook. So you see here we have a add the project option. So we need to first create a notebook inside the project, inside our project. You can create multiple notebooks, as I said before. Why don't we go and create a new one? We clicked and you see there's a notebook, and you can also see the description here. What notebook provides us is that we can run our code not from beginning to end, but we can run it like a single block of code. Like we don't need to run it from the beginning as we change something in the end. We need to if we just change the end of the code, we can just rerun the end of the code again, if we don't need to run the beginning part. So let's go to the notebook, and you see there is the notebook creation page. So let's give a name for our notebook, like demo notebook here. Great. So we gave a name. So we will write our code in Python 3.5, and also you need to select our runtime, like default Python 3.5 x small XS, 2 virtual CPU, and 8 GB RAM, which is totally okay for us. So and it's also free. So we need to go to From URL tab, and we need to provide the notebook URL. In our case, we are not going to write the notebook from zero, like from the beginning. We will import a notebook. We will import a recently written notebook, which I wrote before. You can find it in the GitHub page. So we need to go to our GitHub page, and you see in the guideline, you see the link here. You need to copy that link and go to the notebook creation page and paste it here. So what it will do is that it will get the code inside that link into our notebook. So if we click on create, it will basically clone the code from that repository from here. And what we change will not affect the GitHub page. It will just stay in this project. So you can easily do it in other projects to work from other people's notebook. So this is the IBM Watson Studio's Jupyter Notebook main page. So when you download imported a notebook from a GitHub page, you will be seeing your code in the GitHub repository exactly the same in here. So when you want to, you can move on from this and from this workspace to improve your notebook. You can write other capabilities. You can add functionalities. Also, you can add collaborators to work collaboratively from here, from IBM Watson Studio, which is a very nice feature. So what we will do is, I'm going to introduce the notebook from beginning to end, but first we need to import our dataset and insert our credentials to this notebook, because Cloud Object Storage is connected to our Watson Studio service. However, in this particular notebook, the notebook itself cannot see our cloud object storage, since we didn't provided the credentials to access the cloud object storage inside the notebook. Therefore, we need to add the dataset inside this notebook and also insert the credentials inside the IBM Watson Studio Jupyter Notebook. So, first of all, you need to go to top right, and you see the 1001 section. You need to click on that to import the data from your GitHub page, from the GitHub page, the code patterns GitHub page. So just click it. Here you see files and connections. You can make connections here, also upload files here. So you can please go to the GitHub link, the code pattern GitHub link, and let's go back to the main GitHub page of the code pattern, and just go to this kchousedata.csv file and download it into your local computer. Since we will need it inside our IBM Jupyter Notebook, so just go and click on Browse. Here it is. I downloaded it here. I will just click on the file that I want to import and just click Open. You see in the right sidebar our dataset is going to be downloaded. So it is downloaded. The dataset is inside our Jupyter Notebook, but it's not inside our code. So we need to insert the credentials to access the cloud object storage which this dataset resides. Therefore, so we don't need to write any code here to insert the credentials. What is a really nice feature is that you can click on this insert the code part here, and you can either insert credentials or insert pandas data frame. And since we want to access our dataset as a pandas data frame in our specific case, we will click this insert pandas data frame. It will also insert the credentials to access the dataset that we provided in cloud object storage. So we just click on it. Make sure that you are on you clicked once to the first cell of our Jupyter Notebook. So just click it and just wait a few seconds, and then here it is. You see it imported this line of code itself automatically. What it does is that it inserts your credentials, your cloud object storage credentials, service credentials here. And it is reaching our dataset from here and saving it as dfdata2 in our Jupyter Notebook. So as we did in the code pattern, we need to convert the name into df. We are going to use the dfdata2 as df. So let's do an assignment here just to make sure, or we can not write it. We shouldn't write it. We can just delete these two, dfdata2 to df. So when we run it, it will work. So let's close the sidebar, and then I should have introduced you here the Jupyter Notebook. You see this part completely is a cell which you can execute as a single as itself, and you may not write it whole, may not write the whole notebook as I said before. You may execute just this block, this cell itself. So let's do this. You go to the panel top and just click cell, and then run cells. So it will just run the first part itself. So it gave an error. What was the error? The error is that we are using df here, so we need to clean this up just for these things. So your code should look like this. Yeah. And when we click run cells again, see our data set is here. Great. So it's not only executes this line of code, it also shows what its outcomes presents. So you see the ID field is here, also date field is here in date format, also price, bedrooms, bathrooms, square footage of living, and so on. You can examine this by sparing it a time, and that's it. So we successfully uploaded our dataset inside our Jupyter notebook by giving credentials automatically. So that's great. The next part is we're going to run the notebook. However, it will not work for this time because we didn't initialize the communication between chatbot. We didn't even have a chatbot right now. Also, we didn't implement the WebSocket communication protocol. I mean, it is created as a code. If you go to bottom, you see the WebSocket communication is created here. However, the IP addresses and also port numbers, or WebSocket path is not defined. So what we need to do is this time we can leave it as it is, but we need to run the code until this part. The reason is that okay, let's go and I will explain the code until that point, and you will understand the reason why. So this part is just printing the dataset that we imported. The other parts are this cell just drops the columns, excludes the columns that we didn't want in our modeling. You see, ID field is not descriptive enough to give a modeling insight. So we need to extract the ID from our data frame. Therefore, we are using these functions to exclude these features. So we will execute this code, clicking cell and run cells. You see, if there is a number here, it says it is executed, and the number itself represents the sequence that it is executed. We executed this twice, so it's 2. We executed this one, so it's 2 plus 1, 3, and it will go on like 4, 5, and you understand that. Good. Now, to make sure that we have, the column fields you see in the above are not descriptive enough. It's not human readable, so we need to convert it into human readable format. So we click cell and run this cell again. You see, this is the unique items that we include in our dataset, the date feature set. So we need to convert it to date format. This part is just for demonstration for the capabilities. So we will not mainly use this in our dataset. So you see, when we executed this cell here, and then we executed this cell here, we see that date fields are much more descriptive enough. So that's good. But we will not use these date columns as in our code pattern. Therefore, we need to drop it again. We click cell and run cells. And we also dropped the date columns. The other cell below here is what this does is it gives a descriptive information about columns such as column name, type, null values, existence, and so on. So, which I wrote. And if you execute this, it is defined in the dataset. And now, if you execute this column, you see there is a description of the columns one by one, like its name, its type, null values exist, and so on. By the way, if you click this part in the name, in the left side, you can examine the whole output one by one. But since we don't want to make it, to cover all the whole page, you can just excuse it by clicking here. That's good. And once we extracted some information about the features, we need to gain more insight, like which features correlated with other features. So we need to observe the relation between different features, like if one is increasing, the other one decreasing, or they are both increasing one by one. We need to compare each column to each column. Therefore, I wrote a cell code block for that purpose. We're going to cell and click run cells. What it does, it displays the data set as a correlation matrix. And you see here, there are some colored parts which gives an information about correlation coefficients. So you see in here, in the right side, if it goes to 1, it's like they're totally correlated to each other. So you can go and select some place, and you can examine the relation between different fields. For example, number of bathrooms and number of square foot living. Square footage place of living we examined the correlation between the different fields. We can also prepare our data to normalize the columns, because in modeling we need to have columns which should be in the same range, since our model will maybe distracted, or how can I say, they are biased. They may be biased to some feature. So we need to make them in the same range so that it will not affect negatively in our data set. Therefore, you need to go this cell and run this cell too. And if you go to other cell and also run that cell, we see that the ranges are between each column ranges between -1 and 1, which is what we want to train our model. That's good. And this part is the last column that we need to execute right now. What it does is that it will go and it will create a download link for our data set. So if you go and execute this cell, you will not see this part in the code. If you go and run the cell and wait a little bit, you will see the download link here, which is, we prepared the data set, we need to export it, since we need to give them in IBM Custom Machine Learning Model Builder to identify which algorithm suits this prepared dataset for our business goal. Therefore, just click on this download CSV file option. Things, and we need to go down to associated services section, and you see here there is a plus sign and an add service text. You need to click on that, and we need to go to Watson. Here you see we can bind other IBM Watson services with IBM Watson Studio. Here we need machine learning service, so we need to click add. You can see your existing machine learning services from here, but since we don't have any right now, we need to create a new one. So we go below to the plan and select light plan, which is free with a limited usage. So we need to create that service. We can give a name, specific name to our machine learning service, like demo ML, demo machine learning. It will take just a few seconds, and then our machine learning services will be created. And what we will do is we will going to upload our exported data to this service to make it work. Yes. You see here in the associated services section, we see our machine learning services created. Great. Now we need to go to assets page in the above panel. You click on that, and we need to go to, you see here, model sections is created since we have a machine learning service. Now we need to create a new Watson machine learning model. We need to click on this, and we will be directed to the creation page, and we will give a name, our demo model, let's say, and we will select the type from model as model builder, and we will select the runtime as default Spark Scala 2.11. Great. And here we need to choose manual, because I want to demonstrate you which models we can select. Then click on create. We need to wait a few seconds. So now we will be directed to select data asset. Now here there is a data asset which is the not prepared data set. We need to give our data set here. We need to go to downloads, and data CSV file you see here is our file that we need here. We need to choose that file. It will take just a few seconds. Yes, it is downloaded. Now we see here we can select our prepared data set. You will select that and create next. Now we can select the technique to make our model work. For example, here we need to select the feature that we want to predict. So we need to predict the price of the feature, the price of the house, and then the feature columns we will select all, since we excluded it within our notebook. Great. Now we will select the type. We can choose here the types of the algorithms. We will choose regression. And then we will go to right at add estimators and we will choose all of them. We will click on it. See here we are configured our regression algorithms, but we haven't started it yet. See here we can select the split validation splits like train percentage of the data set and test percentage and also holdout percentage, which is great. And then we click on next to execute these estimators to work. So we accidentally put more than 8. We put them twice, so we need to delete these datasets, the algorithms, because we already have these. Great. See here, all the algorithms are tested on our prepared dataset. We need to wait a few minutes to make it work, since it takes a lot of time to process these algorithms. And here you will see the squared root mean squared error and other error types, also R-square or other detailed explanations, other error types here. After the completion of the queue, of the algorithms in the queue, we observe the outcomes here. Like if we can say that if our errors are small enough, we can choose the algorithm that suits our needs. So let's have a look at the root mean squared errors. We see that random forest regressor has the least mean squared error, root mean squared error, and also in this case we observe that mean squared error is also the least here, and also in this case we need to choose the highest R square. So we are looking at it and we see that random forest regressor also gives the best result. So, and we observe that mean absolute error is least in gradient boosting regressor. However, since we have means other errors are least in here, we will choose random forest regressor. If you may have different results here, like different errors here, according to your model builder. However, the results are almost the same here. So you may confront that gradient boosting regressor may have less error than random forest regressor. However, we can choose whatever we want since they're very close to each other. So we will choose random forest regressor for our modeling. Great. Now we will save our outcomes here so that you can reach it any time we want. So we are saving our model. Great. Now that we concluded our first part of our application, of our code pattern, now we concluded that we will predict the price according to random forest regressor modeling algorithm. So it is time to connect the other parts of our code pattern to our Jupyter notebook, to our Watson Studio service. See you in the other video. Welcome back again. This time we're going to use other IBM services, such as IBM Kubernetes services, to use IBM's other open source service, which is Node-RED. And Node-RED service will help us to create a WebSocket communication between Watson Studio and Telegram chatbot. Therefore, we will use Node-RED service to make it more quick, make it more rapid, to gain the better response. So first of all, in order to install Node-RED into our Kubernetes service, we're going to create IBM Kubernetes service cluster. So go to the catalog here from the dashboard page and click and you will see in the main page that IBM Kubernetes service is here. You can, if you're not seeing this, you can just go to this catalog search and write Kubernetes. So just click on IBM Kubernetes service to create a new instance of it. Now we see that IBM Kubernetes service is created, can be created by clicking here. So you may observe that you can also create a free cluster here with a one worker node in it without paying any fee. That's great. So let's give a cluster a name like demo cluster, and we will leave the geography as it is. It doesn't matter for this purpose, so we will leave the resource group as default and we will create a new instance of it. Just click on create cluster. You will be seeing this cluster main page, which helps you to configure your cluster and also see the status of your cluster here. So you need to wait a little bit to make your cluster up and running. So you will also observe that it will say here that it expires in a month. If you're not using your cluster in 30 days, your cluster will be removed. So you will see that the command line guideline here, and it helps you to access your cluster inside your terminal. You need to install IBM Cloud CLI tools and Kubernetes service plugins into your terminal, and you can install them by entering these commands into your terminal. So go ahead and use these guidelines to configure your terminal in order to use these clusters. We will wait just a few seconds to make it work. While we are waiting for our cluster to be deployed, I can show you the guidelines how to install Node-RED service into our cluster. So go ahead and click a new tab and click on node-red.org. Here you will see that you will confront the Node-RED service main page which you can find the other library information here. Also, you can find the guidelines, tutorials, blogs, documentations inside this website. So what we will do here, we will go to Docker installation tool service. So go ahead and go down below in the main page, and you will see that run locally option here. So go ahead and click on Docker here to access the documentation. So by the way, you need to download Docker into your computer. So you can see that you can run the latest container in you can install the Node-RED server, Node-RED image into your local Docker. So by following these commands. So let's go and create a new one. So I will open my terminal and I will follow the guidelines here. But first, I need to see that my cluster is deployed. I can refresh the page to see the further details. It is being deployed. So I will wait a few seconds, few minutes again. Hello again. Now we see that our cluster is in normal state, which means that it is ready to run. But we have not configured it yet to reach it, to access it from our terminal. So please follow these prerequisites to install IBM Cloud CLI tools and also Kubernetes service plugin. And also make sure that your Docker is up and running. Your Docker instance is up and running. Great. So now we need to open the terminal and access our account, IBM Cloud account. So I have already done this step. So I will go to next step by entering this command. So let's go to the terminal and copy paste that code. You can also copy paste by clicking here and just copy paste it here. We are setting our region for Kubernetes service as US South. So great, it says okay. Now we will configure our cluster by running this command. We will wait a few seconds to make it configured. So it is configured, downloaded successfully. So you need to copy paste this YAML file here. YAML here. Now our configurations is almost done. We can check our worker node is up and running by going here and entering this command. You see that our cluster is up and running here. It's in ready state, so it's ready to run. Therefore, we will now focus on other part to configure our cluster. Now we will run this command here in the Node-RED page. You will follow me and we will write this command here. Let's clean this terminal. Now we will run kubectl run our Node-RED service. We will give it a name, so we will give my Node-RED image equals node-red slash node-red node slash red Docker. So great. Now let's go and run this command. You will see that my node-red deployment is created, so you will go and expose our port to listen to IBM our cluster. So go ahead and write these commands: kubectl expose deployment slash my node-red type goes not port and yeah, this is exactly the same as it gives me the suggestion. So go ahead and write these configurations to make your port accessible from outside. So enter this command. You see our service is exposed, and now we will write kubectl describe service my node-red. We will see that it is configured as we want it to configure. So it will also, the target port is 1880, and also our endpoints are configured. So now please notice that node port section and copy the 5-digit here. So, and also copy the IP address under the public IP section. Just write IBM Cloud in your terminal. Just write IBM Cloud KS cluster KS workers cluster and write your cluster name. Our cluster name is demo/cluster. Yeah, right. Let's go and check it. Yeah, our cluster name is demo cluster. Yeah, great. Go ahead and you will see that you will observe our public IP and also private IP to reach our kubectl service. So now please copy the public IP address here into your node editor. Please notice that now, after running this code, we see that our public IP is available here to reach our cluster. So we can go ahead and use these cluster IP by entering this into our node-red editor. And also, let's do this once again. I opened it before. Let's close this. Let's go ahead and click our IP address here, and also enter our port number here that we gave here in the node port section. Just copy this and paste it here and enter this. You will see that our node-red is installed our cluster and it's up and ready for running. So it is a node-red part. See you in the next video. Hello again. Now it's time to create our chatbot to make it ready for our node-red service to be accessed. Therefore, we need to go to catalog, and in the search bar we need to write assistant. So here we see that IBM Lesson Assistant chatbot service is available, and we will click on it and we will create a demo assistant here. We will choose the region as London, and we will choose the light plan as it's free, and we will create. you see that our assistant is created. This is the main page. We can reach the API keys, URLs, and other credentials by clicking on Service Credentials section. But for now, we don't need these. So just go to Manage section again and click on Launch Tool. You will be directed to the Watson Assistant's main page. So let's go. This is the main page of the IBM Watson Assistant. We will go to Skills tab, which our chatbot logic resides. So we will click on Create Skill section. And here we will not create a new skill. Instead, we will import a already created skill that I introduced you in our GitHub page. Let's go to our GitHub page and get that GitHub page. Please go to skill.json file here and download it into your local computer. Go to import skill section in here and choose the JSON file and choose your file here and click on everything and click import. Now our skill is created. It's a sample skill, and I suggest you to watch the tutorials about IBM Watson Assistant to understand the intents, entities, and dialogues. So I will leave these parts as it is. And now we need to go to skill section once again and create the 3 dots here. So we will click on View API Details, and we need to copy this workspace ID into our text editor. I'm copying it. So now we need to go to our Node-RED service instance here, and we need to click on 3 lines top right. So we need to go to import section and also click clipboard. And then we select the file to import. In this case, we need to also go to our GitHub page in here, and we need to download this file. Okay. Let's try this one more time. Yeah, now it works. You will click on import, and you will see that there are some unrecognized types, and it doesn't matter for us right now. We need to go to the WebSocket chatbot flow, and now what we need to do is, this is the Node-RED flow that I designed to make it available, to make our WebSocket communication available, and also chatbot server, and also access to chatbot, Telegram chatbot. So inside Node-RED there are some predefined nodes available. However, in our case, in our code pattern Node-RED flow, some of the nodes, some of the code blocks here are not predefined. Therefore, we need to import them. You need to access them from outside. So we need to go to Manage Palette, and we need to go to Install tab, and we can write Watson. You see Node Watson is available here. We click on Install, and we install IBM Watson nodes available inside our Node-RED service. Now you will see that some of the nodes are available now here, for example, but we also don't have Telegram nodes available. So we need to go to Manage Palette once again and go to Install tab and write Telegram. you need to install Telegram bot here. Click on install and wait a little bit. You will see that these nodes are now configured properly. Great. Now here you can observe that our flow is available, but it is not configured properly yet. We need to configure some of the instances, like our Telegram nodes. So let's also assistant nodes. So let's go and click on assistant node. You will be confronted this page. You will see this page. So click on API key, and please remember that we have already copied our workspace ID here before. So we need to go to, it should be this. We need to copy this here. This should be our workspace ID. Let me go and check once again. Yeah, it is our workspace ID. Now we can also give our API key here to make it again available. Please go to API key section from the assistant homepage and go to your flow and paste it on API key section here and click on done. You will observe that our assistant is now available here, and also we need to set it. We need to set the other assistant node exactly the same. So I'm giving the credentials as we configured in the other node. So great. Now our assistants are configured properly, but our Telegram nodes are not configured yet. We need to configure them also. So now let's go and configure WebSocket nodes before Telegram nodes. Click on pencil icon here and write, for example, what we want to write. This is the path that our WebSocket service is accessible from outside. So we will write, in this case, demo. Let's just write demo. Great. So we will leave the type as listenon and click done, and we will go to other WebSocket node and also choose the path as same as in the other WebSocket node. Now our WebSocket nodes are ready. So let's go to our Jupyter notebook. Yeah, let's go to our Jupyter notebook. Yeah, let's go to, this is the model builder that we had before. We will click on our notebook, click on the pencil icon to reach the notebook. Now we need to configure the WebSocket communication inside Jupyter Notebook. Since our server is available, our WebSocket server is available by this node from the path described in here. So for example, if we give the IP address and port / our path demo, the users from outside can reach the server and send messages to it. So now we need to go to our Jupyter Notebook instance and go below and paste our port and IP address that is here into our Jupyter notebook, like here described. And also we need to, don't forget to clean these HTTP parts. Since it's a WebSocket communication, we need to provide WebSocket. So the path is our defined path in the Node-RED, which is demo. So it's configured properly. So great. Now we can run all to execute these. So let's go down below to start our WebSocket listener. So great, it is listening. Great. Now we need to set up the Telegram bots. So if you don't have a Telegram bot, we will configure it in the next video. Hello everyone. Now in this video we are going to create our Telegram bot inside Telegram application to navigate our Watson Assistant into our Telegram chatbot. So let's go to your phone or your computer's Telegram application and go to the contacts in here and click bot folder. You will see a bot folder here. This is a bot for creating your own custom chatbots inside Telegram application. So we are going to create a bot inside this application, and we are going to connect our Watson Assistant. So let's go on and click bot folder. Now we will say start in here, and then it will introduce us what the bot is capable of. So we are going to say new bot, and after that it asks for name for our bot. We will say like demo bot, but maybe it is taken. No, okay, it's not taken. That's good. We will say like demo/bot, but maybe it is taken. Yeah, it is already taken. So we will say like demo called pattern bot. So yeah, it is done. So you can go to your bot by clicking here. You see we are in our bot. It is started. However, we haven't defined anything, any capability, any functionality inside our bot. So we are going to go back to bot folder, and we are going to copy this token because it's an access token to reach our bot. So we are going to copy it in our editor or clipboard. So now we need to give the credentials to Node-RED Watson Assistant node. So let's go back to Watson Assistant, Node-RED service, and go to Telegram node. Double click on this node and go to pencil icon here to create a new bot. And we are going to give the bot name and token that we have just gave. So what was the name of the bot? It was a demo bot. And what was the token? Token was the token that I copied earlier, and then everything is the same. So let's go and double check if we gave the name right. Name of our bot is demo bot, yeah, and the token is this. Great. Click on add, and now our bot is configured inside Telegram nodes. We need to configure it also in Telegram sender node. So click on demo bot in here also and click done. Now we have configured our Telegram bot so that it will connect our Watson Assistant here and then receive the message from the assistant and then get back it to Telegram chatbot again. So our setup is ready. We will click on deploy to make our Node-RED flow executed. Now our flow is ready. And now let's go back to Jupyter Notebook And we will once again run all cells. Please make sure that your Watson Assistant and Telegram nodes are configured properly. To double check it, please click on Watson Assistant node and you will see that API key, service endpoint, and workspace ID is necessary. So to retrieve those items, you need to go to Watson service page, Watson Assistant server page, and go to service credentials sections here, and click on view credentials here. Then you will see that your API key and URL, the service endpoint, resides here. Great. To check the workspace ID, we need to go to Watson Assistant service. So if you go to Watson Assistant main page and click on skills, you can see that your skill resides here. Then click on the three dots here and then view API details. After that, you will see that your workspace ID is here. Great. Now that we have configured our nodes properly, we will click to deploy and the deployment is successful. Then we need to go to our notebook again and run all cells to make our client listen to the server. Great, our server is started, so it is now time to ask for the price of the house from chatbot. So let's go to chatbot and say, for example, hi. Great, the chatbot greets us, and then we can ask for what is the cost of the house. What's the cost of the house? So it will repeatedly ask questions about the features of the house, and we can arbitrarily give the information that we have here. Great. You will see that the estimation is done and the price of our house is this. So please make sure that if you want to try again another house, you need to go to your Node-RED editor and you need to click on clear context icon here because you need to clear the current input that is given to the chatbot. We can do it by clicking here. So after clicking that, you can go back and ask again the cost of the house, and you can answer the places like this. So thanks for watching my video. Please ask from anything you want by reaching me. So thanks for watching.